Greetings everybody. Thank you for tuning into this video. Today I'm going to speak to you about a special project of ours, the Coolum Beach Christian College, and I'm going to speak about the built environment, not about the teachers or the curriculum, but how the built environment around the school aids in creating a space for learning and how it optimises the outcomes for the college. Coolum Beach Christian College is located on the Sunshine Coast in Queensland, just north of Brisbane, in Australia. We started this project in 1999 when we helped the school board select the site, and then in 2000 we were rapidly into design and construction, with the first buildings going in on site pretty quickly. Over a period of 15 years, the school built itself up to 2 streams, 2 sets of classes per year from prep right through to grade 12. This first video about the college is about its social planning, the master planning and the social aspects, and how these aspects of design can really impact performance, let's put it that way, performance of a college, and in an enduring way, because once you set up the planning and the architectural design, it stays that way for 30, 40, 50, 60 years. And so it's beholden on any master planner or architect to do the best job they possibly can. Indeed, it's beholden on the board of any school to make sure that the environment takes into consideration the built aspects, not just curriculum. My name is Will Marcus, and my team at ARGO Architects and I designed this project around a very good brief from the board. They were concerned mainly about academic outcomes for their children, but also social and spiritual outcomes for their children. And this was very much part of their brief to us as master planners in the first instance, and then architects as we developed buildings for the site. I was very lucky, or we were very lucky, I should say, in that their concern for the environment was true and clear, very apparent to us. And luckily we had the tools to deliver on their brief requirements. So in the first instance, the master plan of any college is the most important aspect. It's where we can get the most enduring savings in terms of operational ongoing costs. Environmental impact can be minimised at this stage, but also it has to do a lot with the way the society of a school operates, and can't underestimate or can't emphasise too much how important the societal aspects of a school community are when developing a master plan. So I'll go through the parts of the master plan so that you can try to understand how we go about this process. And so though there are parts, it all interconnects into one big plan. I think it's probably good to explain to you what a master plan is first. A lot of people think a master plan is just one big site plan that shows where all the buildings are. And at one level, that's the truth. But in fact, I see a master plan more as an operational document. There's written parts to master plans which are incredibly important because they explain why things are so in the drawing. A master plan could be considered like a machine. There are layers inside it that consider hydraulics, topography, people's movements around the site, servicing. There are safety issues with regards to access of fire trucks, ambulances, servicing from the tuck shop, dropping children on and off. So there are a lot of different flows and patterns that occur on a school, and to understand them and then to master them into a master plan so that they're most efficient and safe is the nature of this document. Other aspects that we would consider in a master plan are climate, breeze direction, quality and strength of breezes, sunlight direction, rising and setting of the sun, shadowing. These all play a very important part in determining how the school is laid out. Luckily, in this particular case, we were party to selecting the site, and so we gave master planning advice to the client as they viewed 5 or 6 different sites. And we finally settled on this site on the corner of Arcuna Road and the Coolum Yandina Road, just over 8 hectares, and it was a beautiful natural site. It was a horse stud before we started, and adjacent property was actually a national park, state forest, and a very large block of land, and it rose above us and shed a lot of natural water down to us whenever it stormed. So the site was horseshoe shaped, like an arena, and if you can imagine that the centre and the bottom of the site was the school oval and athletics tracks, and the school itself then sat in the seating around the arena looking down onto the oval. So these are some of the issues that we considered. So with this topography, we were very keen not to use earth-moving equipment. Naturally, you have to eventually use some earth-moving equipment for roadworks and foundations for buildings. We designed the whole college around the existing shape of the site. Doing this saves an incredible amount of money. Bulk movement of soil, although it isn't dramatically expensive in terms of construction, is a big cost, particularly on this site where we encountered quite a lot of very hard rock, and so digging into the ground too far was not something that we wanted to do. It also allowed, and this is really most important, for natural overland flow of stormwater to occur without us having to rechannel it and reinvent the movement of water. The rain, whenever we get a storm on this site, lands on the ground and then flows where it used to flow down into natural gullies, which we maintained and upgraded, down into a little pond and wetlands area before it ran into a culvert under the highway and out of our site. Reinforcing this part of the brief because on the Sunshine Coast, it's fairly typical to get 300 millimetres of rain in a day. That's a foot of rain in a day. And the worst storms that we've experienced on this site over the last 20 years, up to 300 millimetres in 1 hour. So that's a foot in 1 hour. So these are significant storms, and they can create a lot of damage if they are managed properly. And so the master plan had to primarily take this into account. Now, we were lucky in as much as when we first visited the site, and it was a beautiful site, really, or still is, but at the time we walked on with the board and we were looking over the site, which was pastures and forest. A mob of kangaroos came out of the forest and came down in front of us and started grazing on the long grass. And one of the school board members said, wouldn't this be wonderful if we could build a whole school around this and the kangaroos still came down and grazed on the oval? And I said, well, is that part of your brief? He said, if you want it to be, let's try. So based on that, we generated diagonally across the site a fauna and flora corridor, which was about 10 to 20 metres wide. It is the significant amount of water that we experience on this site, with the rainfalls of 300 millimetres or 1 foot in one day being experienced regularly several times a year. And every now and again, the worst rainfalls that have been recorded on the site over the last 20 years have been in the order of 300 millimetres in 1 hour, or a foot in 1 hour. And this is such a lot of water that it needs to be considered as a primary aspect for protecting the infrastructure. So we developed a watercourse which we asked our civil engineers to consider as a natural stream with large boulders in it, so that the water as it came down in heavy storms would crash into the boulders and lose its energy, so that it would not do damage on the way down across the site. The problem that we had was not just the water that landed on the 8.5 hectare site. There was another 150 hectares of water coming down upon us from the state forest. And so when it rained very heavily, we ended up with significant water flows. Could have been very damaging if it wasn't managed properly. So the master planning had to take that into account. And because we had an interest to maintain native flora and native fauna on site, this watercourse became a natural stream with vegetation all the way through. So it also maintained biodiversity, which is a very important part of the master plan, and it flows throughout the whole landscape. So a primary goal that we had as we went about laying out the school was that we wanted to maintain the water cycle on site. Now, The water cycle is a fairly simple natural phenomenon or mechanism where moisture through the day through photosynthesis leaves the leaves of plants and goes into the atmosphere and drops the air temperature as it does so. It's a natural cooling system. And in the morning it lands as dew and irrigates all of the landscape. But this evaporation, or the evaporative cooling that comes from the evaporation, is significant. And on a site like this, we were finding about 4 to 6 degrees Celsius drop in air temperature if we maintained the water cycle. Now, normally with a school design, there'd be very little vegetation, mainly bitumen and concrete around the classrooms. And the problem with this is that you don't have evaporation, you don't have dew fall in the morning. And so this ability to store moisture and energy in water molecules is lost to you. And so you get a heat bubble above the school, and it makes everything a little harder to manage. Decided to work backwards in the master plan. We worked out where all the classrooms might be and the facilities that supported the classrooms, the halls, library, indoor sports hall, tuck shop, and getting to and from the oval. And we mapped how the children might move about most efficiently on site. And then we limited these movements to pathways that varied from about 1 metre to 2 metres wide, depending on how much they would be used. And then we played a what-if game. What if everything else was rainforest? And then we looked at that. And then we could see that wasn't going to entirely work, but certainly it worked for most of the landscape. And because most of the landscape was sloping, it worked very well. There were some areas we decided to turf, obviously the school oval and the 400-metre running track, their lawn, and then an area around the tuck shop, and there's a couple of small play areas for the prep school kids, and then the lower grades that had some lawn around it as well, just to allow for natural milling. But the rest of the school, quite literally, was converted back to its original landscape, or rainforest, which arguably could have been an original landscape quite some time ago. And by doing this, we made a really significant change to the way that the school operated and felt. So from every classroom or every building, you're looking into views of trees and rainforest and not into bitumen and concrete and other buildings. And this made a significant difference to the way that this school feels over any other school that I've ever been in. So the master plan itself shows clearly a ring road that surrounds the main body of the school. So the ring road is close to the perimeter but not on the perimeter. And the purpose of this is twofold. One is that we can maintain children, particularly the lower grades, inside the ring. And in that zone, there are no vehicles in school hours, and generally just no vehicles. There is a road through there for emergency vehicles if there's fire or an ambulance is required. The other aspect is that we have to service the tuck shop and some of the buildings, so we need to have a road in there. But we designed that road through the ring more like a plaza, so that the children use it as a main spine for walking through on a daily basis. The ring road itself is where vehicles can come and go to the school. It's used for drop off and pick up. There's coaches and parents' vehicles, staff vehicles, there's service vehicles, and they generally use that ring road. And we've minimised danger to the children by doing that, but also maximised the efficiency of all the vehicle movements. And as anyone knows who has had to deal with drop off and pick up, that can be a nightmare. So by having a ring, it allows us to distribute the drop off and pick up to classes. Now, on top of the ring road, we came to a conclusion with the board that certainly in the primary school and the middle school, for what GLAs, general learning areas we call these, that a format of 2 classrooms adjacent to each other with a movable wall in between and a small room that's accessible from each GLA would be the best format. The small room could have a multiplicity of uses. It could be for the teacher's aid, it could be for tutoring children separately, it could be for storing equipment. There'd be 2 teachers in this double classroom unit, and if they decided to pull the wall out, you'd have a double space, which is a form of learning that was used, or is still used, from time to time in different formats. And then these two classrooms are joined by a veranda, but a larger veranda than usual because it's also a learning space, and we typically included a wet area so that it could convert into an art room, and the children could spill out into this area under cover, of course. And these verandas are also where they place their school bags. And in that area, there was also a little facility which we used as toilets for the children, or a storeroom, or a uniform store. The use of that other part of the building varied from room to room. So all of this was designed on the basis that we believed that we could build more square metres or larger classrooms for the same cost as traditional classrooms if we were smart about how we went about the construction. And I'll explain this in another video how we did this, but essentially what that meant was that the space per child in every classroom is greater than you would normally find in any other school. And doing that for the same cost as a standard school was our challenge, which we eventually met. When it came to the building placement, it's like placing Lego blocks on the site to a certain degree. Obviously the topography is very important, but these classrooms were, let's say there were a 2-to-1 ratio, 2 long, one wide. And we were very keen to face the narrow ends of this building towards the rising sun and the setting sun. And this is very beneficial if you don't want sunlight getting in your eyes while you're in your classroom. But it was also to allow us to insulate these walls very much and minimize the exposure of walls to the rising sun, but particularly the setting sun, which gets very harsh. So that meant that there were 2 blank walls, one at each end, the eastern end and the western end, and that the orientation of the main access of each of these classroom buildings was east-west. And so that meant that we looked generally south down onto the oval. Now, in Queensland, looking south is the part of the sky where you'll never see sun. And so we had great views of the sky. We've got lots of natural light coming in without it being direct light, which can be very taxing on the temperature inside the building, and the thermal gain would be unacceptable. And then on the northern side, we drew the roof down very tight over the veranda so that it was like a big eave, like a big brim on a hat. And this southern and this northern wall are fully opened. So on the southern wall, we had huge banks of louvers, which allowed breezes to come and go. And on the northern wall, facing straight onto the verandas, we had sliding glass doors, which packed away and allowed for any amount of air to come through the building. The importance of this is that on this particular site, but generally in Queensland, the prevailing breezes through summer, which is when you really need them, is from the north to the northeast. There are some breezes that come from the southeast, and so this allowed us to take advantage of these breezes by opening up these walls and having the air move through the building. We also, and I'll explain this in another video about this college, we put a fly roof over it, which really was really critical in lowering the air temperature inside the building significantly. But with the placement, what we did was we made sure that the forests that we had everywhere surrounding all the buildings absolutely and always placed to the north and the northeast of every classroom. And that meant that as the breezes came in onto the site, they had to filter through a forest first, then come through under the veranda, the eaves of the veranda, through the classroom, and then out through the louver banks to the south. And this modified the air significantly. It filtered the air first through the forest. It dropped the air temperature quite a lot and modified the humidity. And all of these things were designed specifically to make being in the classroom as pleasant as possible. Another important part of the master plan decision making was that we wanted the placement of the buildings to enhance the ability to learn. And so that meant controlling views. And so views were important for many, many reasons. One is that we wanted children to be able to look at natural environment without the distraction of looking onto playing grounds or paths. And so the buildings were all elevated, usually about 3 metres above the ground. But because the ground was sloped, we started to get undercrofts under the buildings, which we discovered very quickly in our planning was a very useful place to having covered play. In fact, this school has more covered play areas than any school, I think, in Australia. So for every classroom, there's the same amount of space for undercover play. And we developed these areas all across the school with forests around them. But primarily what that did was that it allowed the breezes coming through on the upper level to be filtered through leaves, through palm fronds and melaleuca leaves. And so this modification of the environment had tangential benefits, which we hadn't initially planned. And so the views from a desk in the classroom became important for us, and we started mapping what they might look like. So wherever you were in a classroom, you had a great view of vegetation or the sky, but no view of any other child moving around, potentially distracting you from your teacher or what you were trying to do in the class. Now, because we were elevated and we were on a sloping amphitheatre that led down to the oval, we had opportunities to connect these classrooms together. And so we made sure that we had good spacing between each classroom block, enough to get a little forest in there that functioned, and enough forest so that you couldn't see the next classroom from your veranda. But we linked all of the classrooms together with bridges, timber bridges, and then we connected them down using ramps and stairs onto the oval. So despite the fact they're on multiple levels, and even though there are stairs to do connections between levels, the whole school is connected by ramps so that disabled people access is not a problem. To summarise the important aspects, or to describe the outcomes, I think is probably the best way of putting it, that we achieved with this type of master plan. I can assure you that the kangaroos still come down in a mob twice a day to graze on the oval, even after 20 years of habitation by humans. The stream and wetland is still being developed, but it is successful in that it supports the movement of animals and stormwater and insects through the site. For me, some of the biggest impacts are that the respect for the environment that the children have at this school is higher than I've ever experienced anywhere. And I think most of you, if you've been involved with schools in any way, will understand that if I say over 20 years there's only been one graffiti and no vandalism other than one tag, and that was in the first year before we'd really started, it was an outsider. That says very much about the respect for this environment that a nicely planned school can bring. And whenever I visit site, and you have to understand, so there are 350 children in this school at the moment. Once fully developed, and there will be 4 strands of school going right through, there's going to be up to 1,200 children on site. But as it stands with 350 children, whenever I visit, there is never any litter. And it's not because they have a huge team of caretakers picking up after the children. There's just one caretaker who does this, and he never has to pick up their rubbish. Like most children, they'll leave their hat or their bag or lunchbox somewhere, but they don't litter because of the respect they have for this environment. Now, in Australia, we have NAPLAN testing, which is our standardised testing for school children right across the country. So every child in every second grade, so in grades 3, 5, 7 and 9, are sitting down and they're all doing exactly the same test at the same time. And this allows the educators around the nation to understand where there are gaps in education that can be supported. So the NAPLAN testing has shown over the years that the state of Queensland is generally the second bottom in terms of performance for children around Australia, well behind New South Wales and Victoria. And this was a surprising and unfortunate outcome for Queenslanders. But what we can say about this college is that even though Queensland ranks quite lowly compared to Australia, the NAPLAN test for this college are never less than the national average and usually higher. And there have been occasions, and certainly this college ranks highest in its region and quite often in the whole state of Queensland. And there was one instance where one class came through with the highest test of any class in the nation. So although I'd like to claim it, the built environment didn't give those results, but I certainly believe that it helped. I do know that the principal at this school, the curriculum they run, the quality of the teachers they have is also very high. But again, I think that's also a function of the school, that they're attracted to this beautiful environment. So these factors have contributed to year-on-year growth for this college. With all of this rainforest and landscape, surely your maintenance team must be enormous and the cost to the school significant. And the answer is no, definitely not. In fact, there would be less maintenance involved in this school than most. And that's because if you set up a rainforest or natural forest properly, it'll look after itself, as it does in nature. No one goes around national parks trimming and edging and tidying up. They look after themselves, and that's exactly what happens in this forest. So I'd like to thank you for watching, and I trust that this presentation has opened up for you the possibility of enhancing the outcomes of teaching and learning through a strong, built and master planned approach. And please note carefully that this college costs no more to build than any other college or school in Queensland. It committed to the costs set down by the Block Grant Authority, who fund construction for schools around Australia. And this was all done while delivering for the children and the teachers a resort quality environment which was durable and is low maintenance. Thank you for your time.